Know somebody who was asked, what do you do for a living? And they said, I press buttons. And that's kind of what I do too on a keyboard. Anyway, here you can see our research vessel, the RV Fulmar, and today we're going to be talking about listening related to sound and how we can use that to protect wildlife in national marine sanctuaries. So as you came today, there are generally 5 senses that we use. And I want you to think about what sense you used to get here today. I'm guessing it probably wasn't taste. It probably wasn't smell or feel. It was probably sight, right? But when you're using sight in the ocean, it doesn't really work as well. As you can see, these different colors, those are the different wavelengths of light and how they go down into the ocean. And, in just a few meters, the red light disappears, right? The light that goes the deepest, which is to about 100 feet, is the blue light. So when you're scuba diving or you're putting a camera down there, when you go deep, everything starts to look blue. And as you go down to around 200 meters, there's no light at all. So what you use to get here, your sight, isn't really good for animals at sea. So I like to think how we use sight, they use sound. Sound moves a lot faster in the water than it does on land. So in those old movies when a diver was lost and he's banging on the side of his tank, you wouldn't know which direction he was from because it hits both sides of your ear quickly. But it moves fast. The other thing is that sound can travel very far in the ocean. Dan Hafley was around in the mid-90s when there was a project, the acronym was ATOC, Acoustic Thermography of Ocean Climate. And the idea was they make a sound here on this side of the Pacific, and you listen on the other side of the Pacific, and because sound moves faster or slower in the ocean based on the temperature, they figured they could get an average temperature of the ocean by how long it would take to hear the sound that was made here. So when we have hydrophones, which are microphones in the ocean, we can hear low frequency sounds, right? These deep sounds that are in Hawaii, we can hear them here, especially if they're in certain layers of the ocean. So that's why animals use sound in the sea. And these are some of the ways that they use it. They use it to find prey, listening or making sounds that reflect back like bats do. For navigation, they can talk to each other. They can see in the dark if they're going to bump into some things. They have social interactions, working in groups to catch prey and to find a mate. So these are all things in biology that animals use just pretty much for most things for sound. They do have eyes. Many of them do, not all animals do in the ocean. But they're mostly using sound. So I just talked about some sounds that the animals make. You can see there. But there's also sounds that are abiotic and natural. And those are like you can hear rain. You can hear earthquakes. You can actually hear wind moving along the surface. And actually, when they're measuring the rainfall at sea, it's not by measuring how much goes into a bucket. It's the sound of the rain hitting something. And it was actually measured here and developed at Naval Postgraduate School. They were dropping water in an elevator shaft. So those are abiotic sounds, biotic sounds, and then anthropogenic sounds are the sounds that humans make, like seismic surveys where we make sounds that go to the seafloor and bounce back to see what the seafloor looks like, or a different kind of sound that goes deep into the crust so you can see where earthquake faults are, or ship noises. Fishing boats use echo sounders, and so do scientists to look to see where fish populations are that they can catch. Some fishermen use pingers on their nets that make sounds that'll help the animals avoid where the nets are. And then there's sound when we're trying to do things like develop offshore wind energy, and I'll talk about that a little bit later. But not all organisms can hear sound the same way. You've probably heard of dog whistles, right? The dogs can hear it, we can't. My nephews once set up their phones so that they could signal each other at a very high frequency sound like a mosquito, and they could hear it, and they were laughing because none of the adults could. Our hearing gets a little worse as we get older. Those are the sounds within the different frequencies at the bottom, right? There's a range. We make the orange type of sounds, and that the greenish sounds are what animals can hear. And one of the most interesting things I learned in the last few years from this area is that animals take advantage of these sounds. So one of the smallest mammals we have in the ocean is the harbor porpoise, smaller than the sea otter, and we have them here on our coast. And when they communicate with each other, they communicate at such a high frequency that their predator, the killer whale, can't hear them. So they're communicating. The problem with these really high frequency sounds is they don't travel very far in the ocean, so you don't hear them unless they're right near the hydrophone. The other thing that we learned is when fishermen start using seal bombs to chase away animals that might get caught in their nets, the harbor seals, the harbor porpoise, not the harbor seals, they either stop talking or leave the area. Okay, I wanted to play a few sounds. This could be really loud. We were struggling with this a little bit. I was going to click on these, but instead what I'll do is I will take you to another website that you can check out. It's called the MBARI, Monterey Bay Aquarium Research Institute Listening Room. And you can go there, which we're going to do right now. See if this works. Hopefully it does. And you can first, you can listen to a live broadcast. This is what the top of the website looks like. And here on a cabled hydrophone, what the sound is in the bay at any time. Unfortunately, it's not working this week. It should be working next week. But there's some people in our office that leave that on as background information at their desk. And sometimes they'll send out an email. Oh boy, the humpback whales are really singing right now. You should check it out. But if there is nothing going on, there's recorded sounds. Let's see if we can get some of this to work, like the gray whale. The gray whale, I just click on that, and then you go down here. It's my favorite sound in the sea. Let's see if it works. It could be kind of loud. To me, it sounds like they're trying, it's like a human trying to talk underwater. It's a much more gentle sound than if you heard this coming at you. The killer whale, or the orca. Kind of terrifying if you were a harbor porpoise. It's also a little bit loud. I didn't play it for very long. The blue whales have different kinds of calls. You can see these two. We'll play. This is called the beak. A little bit like a foghorn. I'd play it louder, but it's kind of noisy. And then I'll just play the sound that most of you are probably most familiar with. It's the humpback. Oh, that's actually a marine mammal community. That's all of them. This is a humpback. Yeah, it's playing. I can see the thing moving there. At any rate, I don't want to spend too much time on it, but if you want to, because it's really loud here and I couldn't figure out the adjustment of the sound, it's fun. It's either listen to what's going on in the bay or some of the recorded sounds. You might want to check it out. Okay, other sounds that they didn't have there were, like here, the seal bomb. Actually, I can take out my pointer. And these are essentially a quarter stick of dynamite that the fishermen throw in the water to chase away sea lions that are getting in their nets. However, some people think these things are like dinner bells to the sea lions because they'll jump in and out of the nets. And then later on, I'll show you about a site called Sanct Sound where here's a cruise ship And we actually recorded it coming into the Monterey Bay and leaving, and it went right over one of our hydrophones. There's a whole story about how you can hear it coming in. And then we heard those are low frequency sounds, and we heard some really high frequency sounds when it was anchored. And we think that they used some sort of high frequency sound to clean their hulls from biofouling, things living on them. But we're still learning about that. Okay, so those are some sounds in the sea, and these are some ways that we listen with these underwater hydrophones, these underwater microphones called hydrophones. Some of them are moored to the bottom, right? This is the listening area. We have gliders going around the bay and across oceans, and they'll have a little solar panel on top, and they have like blinds below that when the waves move them up and down, they move forward. They can go through hurricanes and survive them. Some of them are pulling hydrophones. Some of the bigger ships are dragging hydrophones. Some smaller boats will just drop them over the side. In some cases, we'll go out to sea, and when we want to know what sound an animal makes and we see them coming, we'll throw a drifting hydrophone in front of where they're migrating. They go through and you can hear them, and then you can pick it up, or you can let it drift around for days or weeks and then pick it up. James Faldbush earlier today talked about hydrophones that they actually attach to animals so you can see the sounds they're making. And then in some cases, we have sounds, telemetry tags that are on fish or mammals, and most interestingly lately on white sharks, it makes a sound so we can hear them when they're swimming by. And there's a lot more white sharks out there than you would think. I'll leave you with that. The Sanctuary program has what we call our West Coast Sound Observatory Network. These are the kinds of hydrophone setups that we normally use. There's an anchor at the bottom. It could be an anchor, it could be a sandbag. This is an acoustic release, so that when you want to go and pick up your hydrophone and listen to what it's been recording, you go over the general area with a boat, you make a sound, it hears that specific sound, it opens a hook, and then the buoy pulls it to the surface, and then you have the hydrophone here with some batteries in it, and then a temperature sensor, and you turn that out, and then you drop it back down to the bottom. So in many cases, these hydrophones, you don't hear the sound until you pull things back and you hope everything worked. The acoustic releases don't always work, and sometimes you have to go old-fashioned and drag a hook around the bottom and try to get it. But there is one cabled hydrophone on our coast, and I'll talk more about that. But you can see that every one of these red dots is a hydrophone. And that's pretty impressive. I'd say that, 10 years ago there was one, and it was right there, and it was with the Navy. So we're really doing a good job of getting more hydrophones out there and listening. And with that, we can start to get at questions of ecosystem indicators, measuring change, evaluating management strategies. But first, let's look at this spectrogram. What it is it's looking at different frequencies through time, right? So that's a high frequency, this is a low frequency, and then the colors are how loud or how much of that sound there is. So if there's a lot of red, it's a lot of sound. If it's a lot of blue, there isn't so much. And what you can see at this hydrophone in the Monterey Bay is that sound changes through time. Every so often at this frequency, it gets pretty loud. Down here, it can get pretty loud sometimes. These frequencies at that depth could either be from large ships coming by. There's a ship that came into the San Francisco Bay a few years ago called the Benjamin Franklin. We could hear it coming and going for 12 hours. And some people think, oh, that's got to be horrible for the animals. But as a big ship with a big propeller, it made a sound at a deeper frequency than the whales normally communicate with. And the big ships, but not super big ships, they make the sound at the same frequency that the whales communicate. So it might actually be better to have fewer big ones. We're still thinking about it. Anyway, so you can see changes through time and measure them. And this is a symbol of what the Monterey Bay National Marine Sanctuary soundscape of all these different kinds of sounds looks like. About half of the sound is made by animals, A little more than a quarter is made by human activities, and a little less than a quarter is made by natural sounds. And these can vary with season, and they definitely vary from one sanctuary to another. And we can see then in different management strategies how these, this is like a big simplification of something like that, how these things will change if we change shipping lanes or ship speeds or something like along those lines. So with this observatory network and a big partnership of it, I'll show you all the partners later, we can do things like tell what species is present, because different animals make different sounds. We can hear them and we can know, oh, who's around out there. We can do restoration. For example, healthy coral reefs have a certain sound from all the animals living there. If it's an unhealthy reef, it sounds different. So you can put recordings out there that sound like it's healthy to attract animals to come. For example, they do that in the Florida Keys. You can see how effective some of your regulations are that you're trying to decrease sound, if they work or not. You can start to look at things like shifts with climate change. There's a graduate student at Scripps that listens to fish, and she's describing the fish communities just by listening, and she's going to see with time if, as the climate changes, if the sounds change and if the fish are moving. And so we can measure change and look at human impact. So those are all the kinds of things we can do with this network. And these are all of our partners. I mean, it's nuts. One of the beautiful things about working in the Monterey Bay area is that we have so many research partners. These are our national partners. Our big ones around here are the Naval Postgraduate School. They're experts at sound because they've been listening for Russian submarines, since the Cold War. MBARI, the Monterey Bay Aquarium, is a huge partner in this effort. The Central and Northern California Ocean Observing System. All of these people are involved with this project, and it takes partnerships to do everything at sea, really, because it's expensive and it's hard. Okay, so here's some recent findings. Will Oestreich is a scientist at the Monterey Bay Aquarium Research Institute, and he was taking data from their cabled hydrophone. So 24/7, they're listening, they're hearing, and the data is pouring through this cable. Nobody can sit there and listen to it the whole time. I mean, a lot of graduate students and undergrads are sort of used as kind of slaves to do that kind of work, but not even they can do it. So we're teaching machines and AI to listen to certain sounds. And what Will found was really interesting. He was just listening to sperm whales. We thought they're not around here that often. We don't really see them. But if he started measuring how many days he could hear them feeding in 1 year, right? And this is the average days per month that they could detect them. I don't know why it goes up to, this has got to be a percentage. Yeah, it's not 100 days per month. I just confused myself. So these are averages with there's some error around them because they're different days per month. And you can see that, to our surprise, the sperm whales are here feeding throughout the year, maybe a little less in July, but they're here all the time. We found the same thing with beaked whales, very sensitive animal to sound. Navy's really concerned about it. We didn't think they were around because they barely come to the surface and they stay deep for a long time. Turns out they're around quite often. And then as he looked through years, he could see kind of there is a seasonal pattern. But for 7 years, these sperm whales were around. So that's an interesting way to track animals. Part of my job is to know what's living there and how it changes through time, and this is one new way to do it that's a lot cheaper than sending out a bunch of boats with people with binoculars. Here's another really interesting study, again led by someone at MBARI. His name's John Ryan. And here's one of our hydrophones. It's called the Mars hydrophone, and it's a cabled hydrophone. The cable goes from there around to MBARI, and they're listening. And what's interesting about this hydrophone is it doesn't just hear things, it tells you what direction things are coming from. So what John did was he listened for blue whales, and he said, are they in this area, in this area, in this area, or in this area through time, and how does that change, right? And what he found was it in fact does change. Sometimes there's more of them. If you look at this orange out here, 46 versus 2. Other times there's fewer here and there's more there. And he started to correlate that. These are call sounds with visual observations by whale watching companies, with depth, and with upwelling. So seasonally here we have winds that push the surface waters offshore. They're replaced with nutrient-rich water from the deep. When that happens, a whole bunch of plankton grow, then you got a lot more krill, and then the whales start feeding them. So what's happening is the whales are, when there's a lot of upwelling, essentially what they're doing is they're following the food, right? So when there's a relaxation, not so much upwelling, they end up further offshore. When there's upwelling, they end up near shore. And why does that matter? Because these are shipping lanes. And we want to keep the whales from getting hit by ships. And there's also, you've heard about how whales are getting caught in crab gear. And so if we can tell where the whales are by listening for them, we can try to modify when we have crab fisheries. Right now they just like close the whole crab fishery. It could be, it's like, okay, you can fish for crab, but you got to fish where the whales are not. And so that's where I think we'd like to be. Right now I think we're managing crab fisheries with a hatchet rather than with a scalpel. Okay, two major problems with whales and ships is they get hit by them and noise. Now, what was really interesting in 9/11, when the World Trade Centers were knocked down by the terrorists, everyone was terrified. They shut down shipping on the East Coast. And people studying whales found, wow, the stress hormones in whales have gone really down when we stopped all the shipping. So all of this noise causes stress in animals. And the faster a ship goes, as we heard this morning in the first presentation, the more likely the whale is going to get struck by the ship. So if the ship goes faster, it's more likely to hit a whale. But as the ship goes faster, right, this is how loud something is, your decibels. That's how fast the ship is going. All these data points show that when ships go faster, it gets noisier. Right? So what is one effort that the Sanctuaries worked on with the Coast Guard and with the EPA, interestingly, is within the sanctuary boundaries, right? Here's Monterey Bay. That's the Monterey Bay National Marine Sanctuary. Part of the sanctuary is Davidson Seamount. Here we have the Greater Fairlawn Sanctuary and the Cordell Bank Sanctuary, is to put out maps that lets mariners know between May 1st and December 31st when there's a lot of whales. It's voluntary, but highly recommended that they reduce to 10 knots. Some of these huge ships can go over 20 knots. It's unbelievable. When you're out there and you see this monster and it's coming at you so fast. That's one of the things that we're trying to get these shipping companies to do. And why does the EPA care? Because when the ships slow down, it puts out less nitrous oxides and the things that air pollution stuff. But we're also working with a partner to start to track, to incentivize through our Blue Whales and Blue Skies program. You can check out the website to get different companies to participate in slowing down. So this program started in Santa Barbara at the Channel Islands National Marine Sanctuary in 2014. It's picked up by Monterey in 2023. And what we're doing is we're contacting people and saying, hey, do you want to participate in this program? And we'll track you and we can see how well that you're doing and you can brag that you're doing a good job. What we've seen is that companies participating has gone from 7 to 33. The number of vessels participating is just a few. Now we have over 700. The slow speed distance, so the amount of distance they're traveling at a slower speed has greatly increased. Overall fleet cooperation from 0 to 81% is cooperating. A reduction in air pollution gases, a great reduction in greenhouse gases, and overall a reduction in noise. And so it seems like companies are interested in participating, even if it's something voluntary. and we help them be voluntary by creating a website with the Benioff Ocean Initiative, where we actually say you can do a search by passenger ship, container ship, oil tanker, and then what shows up is all of the shipping companies. So let's say you want to go on a cruise and you want to do it in an environmental way. You might look at the passenger ships at this website. You'll see there's Princess Cruise Lines, Carnival Cruise Lines, Lindbad, Celebrity Cruises, and we'll see who's been doing well in slowing down their ship time to avoid whales. It looks like, wow, Celebrity Cruises, you know, almost 90% of their ships are slowing down. There are others, maybe not so well. Crystal Cruise, 9%. They get a grade of F. And so if you kind of want to make decisions on what cruise liner you want to use, it's maybe, you know, they use it as an advertising thing. Like, come with us, we're environmentally friendly. Okay, so sound can also be used to help manage how mammals are protected when there are human activities. Right now we have areas of the offshore off of Morro Bay that are up for lease for developing wind energy plants, and you have to do pile driving, you have to access it with boats and other things. And you might want to do that when the whales and the other mammals aren't around. So we used to do it with visual observations. You're out there in a boat looking. These are huge areas. You can't have that many boats. But if you put out a few moorings with hydrophones, put out a glider, then you can hear when mammals are around. And when you hear them, then because they're endangered, you say, hey, let's stop construction until these animals have left, and then we can continue. So that's an advantage of this newer technology rather than sending people out with binoculars. Okay, here is Morro Bay, right? This is what's called the wind-called area. These areas have been leased for development for wind energy. And so right now, these are those, I told you about some hydrophones you just put out at sea. These are their drift patterns. They're not like a human going straight. They're going around with the currents and the winds. And we want to characterize this area. When I say we, I mean all of these partners, including the Bureau of Ocean Energy Management that manages the leases, to start to know what it's like out there, who's living out there now, before, and then as things are happening. And we can match up all of these different drifting hydrophones, and these are our fixed hydrophones, with observations that are made by sea in certain areas of where the blue whales are. That's the blue ones. I think the red ones are humpbacks. They could be fin whales. Again, we have Morro Bay. But now we have several technologies for tracking where marine mammals are, and sound is a real benefit. So if you're a real, a data person that likes to write scripts and study things on your own, when we now collect data for NOAA, we're supposed to archive it in a way that everyone can access it. So if you go to this website here, you can download all of the sound data that you can analyze to your heart's content. It's available for everybody. We don't hide any of this. And then there's also a website on the Sanctuaries. It's a Sanct Sound website. It's on the website of the Integrated Ocean Observing System, which is a .us site. So if you do IUSE search Sanct Sound, you'll learn more about this project. Why and how we listen to sound, explains in more detail what I said. What kinds of things do we measure, frequencies and decibels, what we've learned. If you click here, there's these cool web stories. If you want the story of what a cruise ship coming into Monterey comes in and goes out and what that does and how it sounds, it's right here. Where do we listen and when? There's another place, if you don't go to the Mbari listening room, you can go here, and there are recorded sounds from every sanctuary, and then all of our partners. So, that's the end of my slideshow. And thank you very much.